Suppose at the dimerization end you have this kind of free radical, a 3-degree free radical, right? Now in order to dimerize, another 3-degree free radical has to be there, and two 3-degree free radicals have to come close together. Now they can't come close together because these methyl will fight among themselves. They'll bully each other, and this 2 carbon having those dots can't come close enough in order to share these 2 electrons properly and form a bond, right? So the rate of reaction would be reduced. Rather, we will have elimination instead of dimerization, and the product will be an alkene. So if we have a hindered hydrocarbon, then the rate of reaction would be less for any dimerization in general, not only Kolbe's electrolysis, for the reason we understand. So these are the 4 things that we should keep in mind regarding Kolbe's electrolysis, right? So the reaction is over. Now let's see how we will deal with the problems relating to this reaction. Now let's solve a few trivial problem in order to be handy with this reaction, right? Suppose the question is, give the product. Right? And I have given you a salt of ethanoic acid. Suppose I have given you sodium ethanoate and I pass electricity through the solution. That means I carry out electrolysis. Now the first thing that you have to identify quickly, it's a sodium or potassium salt and you are passing electricity. That means this is Kolbe's electrolysis. This should strike you very quickly in the examination hall. Looking at the reagent, looking at the substrate. Now you know the product. What's the product? Now how to write that product? Now writing the product will be very easy if we keep track of the mechanism. What's the mechanism? Understanding the mechanism and having the thirst to understand the mechanism is very, very important, because this organic chemistry will become more and more elusive if we don't understand the mechanism, because remembering the entire reactions just at the face of it, just by memorizing the reactant, reagent and the product will not help. It's not possible to memorize all the reactions because there is going to be many reactions, and even if you memorize all the reactions, you will not bear out even a slightest twist done by the examiner. So in order to understand this organic chemistry, in order to develop command over organic chemistry, we have to go by mechanisms. So wherever possible, I'll be giving you mechanisms, and you must understand mechanism first. Thereafter things becomes very, very easy. After studying 8 to 10 reactions, for the rest of the reaction you can predict the mechanism yourself, and life will become very easy. Organic chemistry will fetch you laurels in exam, because there's not much of calculation involved. You can solve problem very quickly. So let's see the mechanism, how the things happen. The first step was oxidation. After oxidation, carbon dioxide gas is released. Now after oxygen you have a dot on oxygen. Now this goes off as carbon dioxide gas. In the next step you have a free radical, and 2 free radicals combine to give the alkane. So what you have to do is, in the salt you remove that CO2 part, and whatever is left out you develop a free radical and just double that, because it gets doubled after dimerization. So after removing CO2 we'll get a CH3 dot, and when we double that we get a ethane. So the product of Kolbe's electrolysis in this case will be a ethane, right? Similarly, if we have a salt of propanoic acid, suppose we have potassium propanoate and we pass electricity through this, then this CO2 will go off in form of carbon dioxide gas, and we will be left with ethyl free radical. When we double that we'll get a 4 carbon alkane with 4 carbon, that would be butane. So the product of Kolbe's electrolysis in this case will be butane. That's how we'll go off. Suppose you have benzoic acid. Now this is benzoic acid. In case you don't know that this is a salt of benzoic acid, remember it here itself, because it's a very important reagent and generally people will not draw the structure, they'll write straight away benzoic acid. This is very common. This is the salt of benzoic acid, an important acid which you must know, right? And if you carry out Kolbe's electrolysis, now this part is going to go off as carbon dioxide gas. Now you will be left with phenyl free radical, and those two phenyl free radical will combine and will give you a very important common organic compound, biphenyl. This is biphenyl, right? So this is how you will predict the product of Kolbe's electrolysis. Now extending the same idea, the question can be reversed. Question can be asked, give the salt from which the following product can be achieved after Kolbe's electrolysis. Now suppose I have hexane, right, and I'm asking on which salt should I carry out Kolbe's electrolysis so that the final product would be hexane. Now hexane will have 6 carbon. I'm not drawing the hydrogens. Now before dimerization, now you have to trace the mechanism backward. If this is the final product, now the penultimate step would be dimerization, and before dimerization you will have this 3 carbon having a dot. So there will be a propyl free radical. Now propyl free radical, before propyl free radical is formed, you must have this CO2 part with a dot on oxygen, right? And before a dot is formed on oxygen, or that meaning before the oxidation process is carried out, there must be a negative charge on this oxygen. So this must be the salt, and you have potassium or sodium, whatever. So if we take this as a salt, then one by one from O minus will have O dot, and this CO2 will go off. Then you will have a propyl free radical which will dimerize to give hexane. So you have to trace the mechanism backward, right? So if hexane is the product, that means this is the acid. That means we have a sodium or potassium salt of butanoic acid. So in order to get the acid, you just break that into half, increase 1 carbon in 1 half, and that will give you the required acid. Simple? Good. So similarly, you quickly tell me I have a butane as the final product. Then what must be the acid on which I carry out Kolbe electrolysis to get butane? Now you must find out the answer. Just listening to me will not help. Now butane is, quickly find out your answer before you listen ahead. This is butane. Fine. Now this has a symmetry. 1 half has 2 carbon. You increase 1 carbon and form a salt. So this must be the salt.